Hi, hello friends. Hope you had a good day and welcome to a new class. And today we are going to discuss about the gravitation. Okay, so before starting into the topic gravitational force, I'm gonna ask you the four questions, and these four questions you have to keep in your mind, and then I will explain each and every one by one. Okay, so the first question is, what is gravitational force? And the second question is, how gravitation works? And the third question is, what is gravity? Okay, how is it different from the gravitation? And then the fourth one is, what are the uses of the gravitational, gravity? So let's start with the first question. What is a gravitational force? So, what is a gravitational force? A gravitational force is a kind of a force is exerted between objects having two masses. Okay, from these objects, suppose there is a mass m here and suppose there is a mass m2 here. So from these two masses, there will be a force of attraction from this mass to this mass, and there will be a force of attraction from this mass towards that mass. So this is called a gravitational force. Anything in the universe which has mass will have definitely a gravitational force. So gravitational force is universal in nature. It's present in all the universe. So along with this gravitational force, there are two other types of forces: the nuclear force and the electrostatic forces. The nuclear forces is again subdivided into strong nuclear force and weak nuclear force. The strong nuclear forces binds the subatomic particles inside the atoms, which is the electrons, protons and the neutrons together. So this is a strong nuclear force. When this atom splits into two, there will be some form of energy released in the form of a radiation. Thus release of energy is called a radiation. In such cases, it is caused due to the weak nuclear forces. So comparing the weak and strong nuclear forces, the strong nuclear forces have much more higher strength and the weak nuclear forces has less strength. But both these forces will only happen if the distance between the objects were at a small level, that is at the atomic level. If the distance between the two objects are at atomic level, these nuclear forces will only act, and after larger distance, after their limit, they won't act. And the second one is the electrostatic force of attraction. The electrostatic forces of attraction are caused by the charges. The moving charges creates magnetic forces, and also the static charges create electric force. It's a gravitational force. It is considered as the weakest force in the nature. And also, this kind of a force will be present if the size of the objects are much more larger. So the size of an object is compare the size of the planet Earth and Moon. These are all big sizes, big sizes. So for these kind of objects, there will be only gravitational forces will be present. No electromagnetic forces will be there, no nuclear forces will be there, because they will act only for a small distance. But in case of a gravitational force, they will act at infinity, which means it's endless. Its range is endless. So these are all about the gravitational force. Suppose there is two masses within my hand, m1 and m2. These two masses were separated by a distance small letter d. m1, m2, and separated by a distance small letter d. The force of gravitation between these two masses, F, is equal to g into m1 into m2 divided by d square. Since I have said earlier, these two gravitational force is a mutual kind of a force, that is a mutual force. So this m2 will attract this m1 towards its center, and also at the same time this m1 will attract this m2 towards its center. Both these forces are same in magnitude, and this magnitude is given by which is the value is given by F is equal to G into m1 into m2 divided by t square. The constant, and there is a value for universal constant G, which is equal to 6.7 into 10 raised to 11 Newton per meter Newton meter square plus kilogram square. Suppose I have said earlier, we have discussed earlier the gravitational forces between two masses m1 and m2. Suppose one of the masses is the earth and the other mass is we standing on the surface of earth. As compared to the earth, we are very small. So the force which is exerted by earth on these small objects, that is us, which are on the surface of the earth towards the center of the earth, is called a gravity. So this gravity is represented by the same equation, which is equal to F is equal to G into capital letter M into small letter m divided by r square, where capital letter M is the mass of the earth and capital letter R is the radius of the earth and small letter m is the mass of the object, that is either us or other objects. So a gravity is a kind of a force which is exerted by the earth towards its center. Without gravity, we can't survive. Without gravity, we can't walk around earth, otherwise we will be floating around earth. And also the atmosphere which covers as a blanket around the earth is due to the presence of the gravity. It is the gravity which holds this atmosphere around the earth. We all know that the atmosphere is the main source of the life on earth, which will not be present if there is no gravity. So also there won't be any objects on the earth if there is no gravity. It will be spread across around the space. Also, even our digestive system can't work properly if there is no gravity. So don't underestimate the gravity. We all need gravity for sustaining our life. So thank you for hearing me for all this time, and I hope you have enjoyed the class. Have a good day and see you tomorrow.